Welcome. Solutions Part 9. In this part, we explain osmosis and osmotic pressure. This is the fourth colligative property. This is the last colligative property, osmosis and osmotic pressure. So we have explained four colligative properties, three colligative properties. This is the fourth one. And first one is relative lowering of vapor pressure. Second is elevation in boiling point. Third is depression in freezing point. And the fourth and last one is osmosis and osmotic pressure. First, let me explain osmosis. Osmosis is the process of flow of solvent molecules from solvent side to solution side, or flow of solvent molecules from a dilute solution to a concentrated solution through a semi-permeable membrane. Here, the solvent molecules are flowing through semi-permeable membrane, and the semi-permeable membrane that will not allow the flow of solute particles through semi-permeable membrane. Therefore, here the solvent molecules are moving, solute particles are not moving. So, this is the flow of solvent molecules from solvent side to solution side, or low concentrated solution to high concentrated solution through a semi-permeable membrane. That process is known as osmosis. The next is osmotic pressure. So, let me ask you one question. When up to what time the osmosis take place, or up to what time the osmosis continues? That is the question. And here, as a result of osmosis, an extra pressure is developed on solution side, and this extra pressure that stops osmosis is known as osmotic pressure. The extra pressure that developed on solution side to prevent osmosis is known as osmotic pressure. The pressure, extra pressure developed as a result of osmosis, and that prevents the process or phenomenon osmosis is known as osmotic pressure. And this osmotic pressure is developed in solution side. Dear children, keep it in your mind, and this extra pressure is developed in solution side. Clear? Then, experiments proved that this osmotic pressure, pi denotes osmotic pressure. Pi denotes osmotic pressure. Experiments proved that this osmotic pressure is directly proportional to molarity, not molality, molarity, M-O-L-A-R-I-T-Y. So, this osmotic pressure is directly proportional to molarity, because osmosis that take place in biological actions or biological activities, and it's a biological phenomena, osmosis. Therefore, definitely the process take place at room temperature. Therefore, here we cannot consider molality. Here we can consider a temperature dependent term, that is molarity. Clear? Molality, M-O-L-A-L-I-T-Y means the number of moles of solute dissolved in 1 kilogram of solvent. And there we cannot consider, that means that is temperature independent. But here molarity, M-O-L-A-R-I-T-Y, molarity, that is number of moles of solute dissolved in 1 liter of solution. Therefore, that term is molarity is temperature dependent term. So, if a reaction takes place at room temperature, means definitely that is temperature dependent. And here, and also this molarity, number of moles of solute dissolved in 1 liter of solution, that is related to volume of solution, and therefore definitely that is a temperature dependent quantity. Therefore, osmotic pressure pi, that is proportional to C. So, here we can write pi is equal to CRT. C is molarity, M-O-L-A-R-I-T-Y, molarity, R ideal gas constant, and then T temperature. And therefore, pi is equal to, you write the definition of C. C is molarity. Equation for calculating molarity is number of moles of solute dissolved in volume of solution. Therefore, N2 by V instead of C, and RT. And N2, number of moles of solute. Clear? And number of moles of solute, we can calculate the number of moles of solute from given mass and molar mass. N2 that is equal to given mass W2 divided by molar mass M2. Therefore, instead of N2, we can substitute W2 by M2 or T, then here V. Rearranging the equation, M2 is equal to W2 into R into T divided by pi V. M2 is the molar mass of unknown solute, and then W2 is the given mass of solute, R gas constant, T temperature, pi osmotic pressure, V volume of the solution. So from this, using this fourth colligative property osmosis, we can calculate the molar mass of molecules like protein, then starch, etc., because this osmosis is related to biological activities. Therefore, we can observe this osmosis in biological process, and therefore natural phenomena we can observe this osmosis. Therefore, using this equation we can calculate the molar mass of unknown solute. Clear? Molar mass of unknown solute can be calculated by this equation. So, in all the colligative properties, we have discussed 4 colligative properties. In all the 4 colligative properties, what we have derived is the molar mass of unknown solute. So, in different ways, we can calculate the molar mass of unknown solute. For example, if you are adding a solute to solvent and we don't know which solute is added to solvent. Therefore, using this colligative properties, we can very easily calculate the molar mass of unknown solute. That's about the colligative properties. We have discussed 4 colligative properties, and also we derived equations from all the colligative properties. From all the colligative properties, we derived molar mass is equal to molar mass of unknown solute. So, using this equation, we can calculate the molar mass of unknown solute added to a particular solvent. Hope all of you got clear idea about osmosis and osmotic pressure.